Welcome back. I hope everyone is doing great. My name is Raviteja. Let's solve today's Leetcode problem 3129. Find all possible stable binary arrays 1. You are given three positive integers 0, 1 and limit. A binary array AIR is called stable if it holds following conditions. The number of zeros, occurrences of 0 in array is exactly 0. The number of occurrences of 1 in the array is exactly equal to the variable 1. Each subarray of array with size greater than limit must contain both zeros and ones. I don't know why Leetcode has chosen such naming convention. It was pretty difficult to understand. Okay, so even though they say exactly equal to 0, it's not exactly equal to the numerical value 0, but this variable, whatever value this variable contains, it should be exactly equal to those many number of zeros. Okay, think it as x. Okay, this as x, this as y. Okay, so the number of occurrences of 0 in array should be exactly equal to x. The number of occurrences of 1 in AR is exactly equal to y, which is equal to the value which variable 1 holds, and it should also contain every subarray which you're going to choose of size greater than limit, okay, should contain both zeros and ones. Okay, so if you see the final array, okay, we have to make an array such that it contains 1 0 and 1 1 in it. Okay, such that the every subarray of size 2 which you're going to choose should contain both zeros and ones in it. Okay, if you see, these are the two possible subarrays where you can have 1 0 in it and 1 1 in it, and every subarray of size greater than or equal to limit will contain both zeros and ones in it. Let's also look at this example. You see, in the final array which we're going to form will contain 1 0 in it and 2 ones in it. Okay, if you see, it has 1 0 in it and 2 ones in it, and every subarray which we're going to choose of length greater than 1. Okay, if you see, this is a subarray which has both zeros and ones. This is a subarray which is greater than length 1, and it also contains both zeros and ones in it. Okay, these are not valid subarrays. These are not stable subarrays, because this subarray is not stable, because if you choose a subarray of size greater than length 1, if you choose this, okay, if you see, it contains both ones in it but not 0. So this is not a valid stable subarray, and this is also not a valid stable subarray. Okay, by this, if you also look at this example, the limit is 2. Okay, that means if you see, the every subarray which we're gonna form will contain these many zeros in it and these many ones in it, and there is a restriction that the zeros, the consecutive zeros which can maximum occur is equal to this limit. Okay, we cannot have a subarray with zeros continuously greater than 2 and or ones continuously greater than 1. Okay, so this is one key takeaway. Okay, just by looking at the examples which I came to derive. Okay, you see, the maximum 2 zeros can be allowed, but if you keep one more 0 over here, then if you choose a subarray of length 3, then it will always contain 3 zeros in it. Okay, for a given use case. So I can maximum allow these many number of zeros continuously, these many number of ones continuously. Okay, so there is a restriction on number of zeros which can continuously placed in the subarray, and there is a restriction on number of ones I can place continuously. Okay, let's say I have chosen to start with 0. Okay, let's have I've kept 0 in the first position. Okay, either I can start with 0 in the first position, or I can choose to start 1 in the first position. Okay, let's have chosen to start with 0 in the first position. If you see, there are options at any given position. Whenever we have options, DP should come into your head. Okay, so I have 0 in the first position. I have two options. Let's say I've gone with 0. Okay, now since I've utilized 1 0, I can maximum have one more 0 next to it, because allow limit is 2, out of which 1 I have already used. Okay, that means I can at max keep one more 0 beside to it. Okay, now again I have an option. right? Either I can keep 0 on it, 0 in the second position, or I can keep 1. Okay, if I keep 0 in it, then my allow limit will turn out to be 0. Then in the third position I cannot keep any 0 in it, so I have to go with 1. Let's say here, instead of going with 0, if I choose to go with 1, okay, if I choose to go with 1, then again, since I have gone with 1, the next subarray which I gonna form from this position, okay, so the next I can have 2 consecutive zeros, okay, because maximum allowed is 2, so my limit for zeros will again turn out to be the maximum limit, right? If I choose to keep 1 over here, okay, if I choose to keep 1 over here, then the allowed limit for ones will reduce, but the allowed limits for 0 is still 2. Okay, so as I mentioned, let's say p is a variable which will tell me what was the previous in the previous position, what is the value, whether it is 0 or 1. Okay, if I choose to start with 0, then that means my previous is 0, then what can I keep in my current position? Since my previous is already 0, okay, if I have the limit to keep zeros, okay, where L will tell the allowed limit for the particular zeros, okay, if zeros are allowed, okay, and if I have the zeros with me, then I will keep my 1 0 at that particular position, and my overall limit for that particular 0 will reduce by 1, and I will continue to keep, I will say the previous is again 0. Okay, if I have ones, okay, if you see the previous was 0, but I have still ones with me, I have 3 ones with me, then I can choose to keep 1 over here. That means my ones will reduce by 1, and my allowed limit for 1, okay, so since I've already placed 1 over here, then I'm allowed to place limit minus 1 number of ones in the next position, right? So that is what I have kept over here. Okay, if the previous is 1, okay, that means if the previous is 1, then either I choose to continue with 1 or I choose to go with 0. In order for me to continue with 1, right, in order for me to continue with 1, I should have certain ones with me, right? I should have ones with me. Okay, if the number of ones are greater than 0, and if the allowed limit for the 1 is also greater than 0, then I will keep 1 in that particular position, and I will reduce ones by 1, and then I will also reduce the limit. If this is one option I have, but I also have an option to go with zeros. I can also place zeros in it. When I can place zeros, if I have zeros with me, if the number of available zeros are greater than 0, then I will keep 1 0 in it, and my overall limit will reduce by limit minus 1, the maximum limit minus 1, because I have kept 0 in this particular position. Then I can have at max limit minus 1 number of zeros going ahead, right? So this is very key takeaway. Since we are flipping it, again the overall number of limits will be the maximum limit minus 1, the allowed limit minus 1, whereas if you choose to continue with the same value, then our existing limit will reduce by 1. Okay, so we only have these 4 options. If I have 0, then I have 2 options. If I have 1, I have 2 options, right? Then let's also look at our recursion based case. Okay, if allowed number of zeros is 0 and ones is also 0, then I will consider this as 1, because I have placed all zeros in the array and I have placed all ones in the array. So this will be considered as one valid binary stable array, right? So where the z is basically the allowed number of zeros, I mean how many zeros I have at the given point of time, how many ones I have at the given point of time, and what was my previous value which I have placed, and what was the limit I have, right? So as you know, we have written our recursion state, right? This is our recursive state. Once the recursive state is written, converting it into the function and memorizing it is pretty easy. If you're following my dynamic programming series, you should be able to easily go ahead and implement the solution, but I'm here to also show you the implementation as well. If you see, Z is taking states from the available 0 till all the way up to 0. Okay, so and also ones are going from all the way from ones till 0. P is basically switching between 0 and 1, and limit is also going from limit till the 0, right? So we need a DP 40 DP array for all, in order to accommodate all these states, right? So if you see, my DP array will be of 0 plus 1 plus 1 plus 1 plus 2 states and limit plus 1, and then I just filled all my DP array with -1, indicating that the answer to none of this is already calculated. Now I can either choose to start with 0 or I can choose to start with 1. If I choose to start with 0, then I have already utilized 1 0, then my limit for zeros will also reduce by 1. If I choose to start with 1, then I've already utilized 1 in it from it, and then my limit will also reduce by 1, and I will say that my previous will be 1 and here my previous will be 0. Let's also look at the function f. Okay, this is just implementation of this straight away. First we'll have the base case. If z is 0 and 0 is 0, then it will be 1. Or if the answer to the current state is already computed, then I will return my answer, or else I will go ahead and compute my answer, right? So if the previous is 0, okay, if the previous is 0, then I have to first verify whether I can continue 0 or not. Okay, if the zeros are available and the limit for zeros is also available, then only I will go ahead and keep 0 in this particular position and I will reduce my limit. Okay, this is one option. The other option is, if I have ones with me, then I will flip it and I will reduce my ones by 1, and I will also reduce the limit for ones as well, which is the given limit -1. Okay, if my previous is 0, okay, if my previous is 1, then this piece of code comes into picture. Okay, if it is 1, then I can flip the next position. I can only flip the position if I have zeros available with me, then this is what the answer will come from. If I have zeros available with me and the limit for zeros is also available, then this is the answer. Okay, and we should also take modulo for the overall answer. Okay, that is what I'm doing over here, and then I'm storing my answer in the DP. Okay, if you submit this, all the test cases will be passed and it will be pretty efficient solution as well. Let's also try to analyze the time complexity and space complexity for this algorithm. Okay, so as you can see, we are filling all the states in the DP array, right? So the time complexity will be big O of 0 times limit 1 times limit times 2. Okay, that is the time complexity, and space complexity also big O of 0 times 1 times limit times 2. Okay, that is what the space complexity and time complexity. Okay, so if you are following my DP series, you should be able to come up with this recursive state. Okay, and you should be able to solve this problem using DP with memoization. Okay, this is standard dynamic programming passion. Okay, the only catch is this is a 4D DP. Okay, so it's always important to look at the examples and understand some pattern from the example. So I came up by looking at the example and came up with this particular approach. Okay, so feel free to check the examples and try to derive some patterns from the example. And if you are curious and want to learn more about the dynamic programming, I have created a playlist, okay, where I have solved all the Leetcode dynamic programming study plan. I have solved the problems from Leetcode dynamic program study plan, and I've posted all the in-depth video solution for all of them. Feel free to check it out. I will be adding the link in the description. I will also be posting the solution in multiple languages such as Java, Python and JavaScript. Feel free to check it out if you're coming from any other programming language. Thank you.